What's up guys, welcome to another video. So today we'll be continuing on the series of automotive basics. In the previous video I talked to you guys about the types of suspensions. So independent suspension, dependent suspensions, McPherson strut, double Wishbone geometry. So these kinds of topics. In this video I'll be talking to you about wheel alignment. Basically adjusting your suspension to properly control where your wheel points. Yes, that's the thing. Now many of you might commonly have this doubt that actually why do I even need to bother about wheel alignment? I mean, I can control where my wheel points with the help of my steering wheel. Why do I need to this wheel alignment concept? Why should I do that? Well, there is far more to this concept of wheel alignment than it looks. Okay, apart from just having control over where your wheel points, it also helps to solve certain number of problems. Okay, which might not seem very intuitive at beginning, like say fuel economy. Fuel economy can also be a problem which can be tackled through proper wheel alignment. Wheel alignment will also affect the cornering, your weight loading capabilities, the tire life, and also the handling of your car. Common problems you might have seen in your car, like say you're driving on a straight road and your car is suddenly pulling towards the left or right. Okay, even though you're keeping your steering wheel straight, that is a sign of bad wheel alignment. Then the tires getting eroded very quickly. Basically, even though you're just driving, in your normal driving style, still you experience that the tires are not holding up for the right amount of time. You are changing up your tires way too quickly. That is also a sign of bad alignment. So now, given that I have told you what are the kinds of problems that can be addressed with just wheel alignment alone, I think it's safe to move forward with the discussion and introduce you to some terms of wheel alignment. And with that said, let's get into the video. So, in the wheel alignment job, you have to take into consideration three main variables. They are camber, caster, and toe angle. Let me just give you an idea of what these are. Okay, so camber is the angle which the tires make when you look at the car from the front. Okay, so imagine you have a car standing in front of you, or a vehicle standing in front of you, and the tires are tilted inwards or outwards. The angle which the wheel is making with the vertical, that is called camber. Okay, if the wheels are tilted inwards towards the car center line, then that is called negative camber. And if the wheels are tilted outwards, that is called positive camber. Then you have caster. So caster, you have to look at the vehicle from the side. So if you're looking at the vehicle from the side, the angle that the steering axis, okay, steering axis in the sense the axis about which the wheel is rotating. So the points, the knuckle joints where the wheel is attached, right? Those are the points through which the steering axis moves, and the angle that the steering axis makes with the vertical when you look at the car from the side, that is called the caster angle. When this steering axis is tilted more towards the driver, that is called a positive caster, and when it is tilted away from the driver, that is called a negative caster. And finally you have toe in toe out. So it is pretty much straightforward right from the words you can make out. Toe in, basically when you look at the car from the top, if the front of the wheels are tilted inwards towards the car center line, then it's called toe in. And if the tires are tilted outwards away from the center line of the car, then that's called toe out. So something like toe in, toe out, toe in, toe out. And one more point to note over here is that the values for camber, caster, and toe in, toe out need not necessarily be the same for all cars. It depends on the type of application, depends on the type of track which you're gonna use it for. Uh, Say if you're using for heavy load application, then one set of camber caster toe. If you're using for high performance, one more set of camber caster toe. And if you're using for heavy cornering, then again a different set. So it is dependent on a case by case basis. Okay, so now let's first start talking about caster angle. In general, almost all vehicles which have the front wheel steering system will aim for positive caster angle. There's a specific reason for having positive caster angle because it gives directional stability to the wheels. For those of you who did not get what directional stability means, uh, take the example of shopping cart wheels. That is probably the best example of explaining positive caster angle because over there, if you check at the steering axis for the wheel, okay, and its intersection point with the ground, that point lies in front of the tire's contact patch, right? And if you have noticed this, that no matter in what direction you take your shopping cart, the wheels will always go along the line of motion of the shopping cart. A similar principle is in effect even in the cars. So when you apply a positive caster angle over here for the uh, vehicle's wheels, that time the steering axis, its intersection with the ground, it'll always that point, the intersection point will always lie in front of the tire's contact patch, and because of this, that tire is it is entering a state of stable equilibrium. When while the car is in motion, no matter what disturbance try to move the vehicle out of that stable position, the vehicle will always tend to move back behind the that intersection point and basically follow the vehicle's line of motion. That is why positive gas triangle is preferred. Also, the effect of positive gas triangle is mainly observed when you're exiting a curve. So you might have noticed how your steering wheel whips back to the normal position. Okay, even without you putting any effort, right? That is a result of positive gas triangle. So when the vehicle exits a curve, basically, say your vehicle is traveling this way, and at the point of exiting of the curve, your tire is somewhat this way. Now there is unbalanced forces acting on the tire's contact patch. If this is the intersection point and this is the tire's contact patch, basically there is unbalanced forces over here if the vehicle is moving this way. So the tire whips back to its normal position and follows the vehicle's line of motion. At the same time, the wheel's motion is controlled by the steering system, right? So there's a tie rod over here which pushes back on the rack. The rack rotates the pinion. The pinion is in return connected to the steering wheel, and that's why the steering wheel whips back. That's why you see that turning thing happening inside the car or inside of any vehicle. Especially in case of loaded vehicles, this is pretty helpful because of the added burden or added load on the vehicle. It is very difficult to move the steering wheel around. So when you are exiting the curve, say at a considerable speed for such a heavy load vehicle, that time, since the wheel itself is tending to move back into that you know normal position, you will have to put just minimal effort from your side to bring it back to that normal position once again. So pretty helpful. Okay, and next we talk about camber. Okay, so in general, again, all cars or all vehicles who try to attain a, a negative camber angle. Basically, if if this is the wheel, sorry, vehicle center line, the wheels would be facing inwards, so or something like this. The camber angle is the most easily identifiable parameters of all the three. You might have seen this in a lot of the auto expos or in the performance cars with the vehicles tilted inwards. Basically, that gives the car a meaner look and a more low rider kind of look. But apart from the looks, it is good from a performance perspective as well, especially in the case of cornering. Because in cornering, what happens is that the outer wheel is there, na, that will try to roll under the car's chassis. So, say if you are driving in a car which has zero camber, okay. So when you enter the corner, the wheel would roll over. So basically, the wheel which was straight up initially, it will become something like this. So the tire's contact patch or the contact area with the ground is minimized, and since the contact area is minimized, you are also sacrificing a lot of friction, and there's a high possibility that you might roll over in the corner, or you might exit the track itself because of not getting enough friction, and that is not a situation we would like. So to compensate for that problem, if we add in a negative camber beforehand itself, So now when the vehicle is entering the corner, of course the tire will roll over even now. But instead of the contact area being minimized now, the contact area is maximized. So that way you get more contact area during cornering. More contact area in the sense you'll get more friction, and more friction is more stability for the car, and that's how you'll be able to perform tight maneuvers. That is the reason for having negative camber. What about positive camber then? When is positive camber used? Positive camber is used again for heavy load application. So when you add more load to the vehicle, the suspension systems would pull the wheels inward. So something like this. Because of this, again, the inner treads of the tire will get eroded more quickly, and your tires will not be utilized properly before you go and change it. To make up for this problem, once again, you use positive camber. So the wheels should initially be like this, and when you add more load on the vehicle, the suspension system would pull the tires in. So now, instead of the inner, only the inner treads getting used up, like in the earlier case, now when you load the vehicle, the tires will return back to its normal position. So there is an even contact patch. So both the inner treads and the outer treads are being properly utilized now. You're not wasting much of the tire's lifetime just because only one side of the tire is getting eroded quickly. That is the benefit of having camber. Cool. So now you know what a camber and caster is about. Now the final variable, which is toe. So in toe we have two types: toe in and toe out. Toe in is used when you're aiming for straight line acceleration and deceleration. If you want very high acceleration or deceleration when you're moving in a straight line, say you're having a long stretch of road, straight road, or you're having your car or vehicle move on a highway, okay, and you want it to accelerate very quickly, then toe in is a good option. What about toe out? Toe out is good when you require very quick steering responses. So since the tires are already in that position of are already in that tilt, so they are ready to take that turn quickly. And this is particularly useful for tracks which have a lot of turns. Okay, where you do not want even the slightest bit of delay in your steering output. In that case, Tote is a very good option. Again, so Toe in Tote have their own applications. So depending on your application, depending on the type of car which you're working on or vehicle which you're working on, you can choose either one of the two. Or if you want to have the best of both worlds, maybe you can go with zero to also. Basically, your tires pointing straight forward, something like this. Instead of doing this or this, just point straight forward. Okay, guys. So that's probably it for the video. I think I have covered pretty much the basics regarding what these wheel alignment concept is all about, why you need it, and what's the purpose of having them. Also, what are the applications of different types of different cases of toe in toe out, or positive camber, negative camber, then caster angle. So that's what you have covered in this video. I may have missed some points here and there, but yeah, if I have missed some points and you noticed it, just quickly mention it down in the comments, and it'll be helpful for someone else who's watching this video as well. So that's it for the video. I hope to see you guys in the next one. See ya.